I like to work in theoretical cosmology because it allows me to use my imagination to try and think of how the universe might be working. I first got interested in astronomy through a teacher at high school, Rob Hollow. When I started my PhD, there was a visitor, Ed Turner from Princeton University, and we started a collaboration together. And this took me to Princeton as a visiting student. Princeton University opened a new world of opportunities in astronomy and cosmology. We believe the universe started with a Big Bang around 13.7 billion years ago, and it expanded very rapidly and cooled. The material became hydrogen gas. This was heated to a temperature of tens of thousands of degrees, and that process is called reionization. It's the last great unknown process in the history of the universe. At that time, there were no galaxies in the universe. It was a very smooth place, but it had small ripples of density, and these density ripples grew to form the galaxies that we see today. Ultimately, we'd like to try and understand how we go from the very first galaxies that form into the population of galaxies of all different types that we see in the universe around us today. My work's illustrated some of the complexities that must have existed. Importantly, it has gone a long way towards using existing observations to try and place constraints on the reionization event and when it might have occurred. People have used the ideas developed in my papers to open up new areas of theoretical research and new ways of trying to simulate the first galaxies and their interaction with their environments. I've had a long interest in rock climbing. Rock climbing has some parallels with cosmology in the sense that it's all-consuming. A particular rock climb took 3 months to achieve, and it required a lot of focus during that time. And I think if to work on a problem in cosmology requires that kind of focus. The most satisfying moment I think I've had in science is when I realised the giant regions of ionised gas that formed around the first galaxies had a finite size that could be observed. And this is something that's very important for the next generation of radio telescopes because it sets the resolution that they need in order to study the first galaxies properly. Looking back, I hope my work will have influenced the way in which we went about observing the epoch of reionization and also will have allowed us to interpret that data in a way that provides us not just with data about the universe, but with an understanding of what that data means in terms of how the universe evolved. I enjoy coming to work in the morning because on any given day there's an opportunity to learn something new about the universe.